The second portion of 2.1 deals with writing equations of lines. Now you can see in each of these problems here, we are given a point and a slope. And what we want to do is write an equation, and we're going to put it in slope-intercept form. We'll put it in slope-intercept form unless it's otherwise specified. But in this case, again, we're given a point and a slope. So that is a indicator for you that you are going to utilize point-slope form, which is listed at the bottom of this page. So all we have to do is plug in our values. The 2 in this case would be my value of x sub 1. The 3 would be y sub 1. So we're just going to go y minus 3 equals 5 times x minus 2. From there, all we need to do is solve for y. So we distribute the 5 through and add 3 to both sides. So we will end up with y equals 5x minus 7. Now you'll notice the next one in letter B is a little bit unique because we are told that we have an undefined slope. Now I can't plug in the word undefined and for slope into point slope form. So here you may want to create a little sketch to help you through. And if you remember what we did or what we learned back in the first presentation of 2.1, undefined slope means we will have a vertical line. So our line here, it goes through the point 5,2, will be vertical. We know that a vertical line will be an x equals line. Well, what does x equal anywhere on this line? X equals 5. And that's all we have to do for that particular one. So that's the only case in which we would not be able to just do a straightforward plug and chug into point slope when we have a vertical line. For these next examples, what I would like you to do for A and B right now is calculate the slopes. All right, in order to write an equation of a line, we need a slope. All right, we have 2 points, we can calculate that. So go ahead and do that and pause the presentation. Okay, when you calculate the slopes, those are the 2 values that you should get. Now what I want you to do is take the slope that you're given and plug that into point slope form with either one of the points that you have here. All right, so for the example on the left, I would like you to use the 0.25, and the example on the right, I would like you to use the point -2, -8. It does not matter which point you use. All right, go ahead and pause the presentation. Try to use point slope form to get the equation of your line. Okay, both of those examples, the step-by-step work is listed there. All right, once you get the 0 on this example on the right, all right, with the slope there, you could immediately, if you want, go right to here. That is fine. All right, but those are the 2 equations of the lines that you should obtain. The last part that we want to focus on is dealing with the slope of parallel and perpendicular lines. All right, you should remember from geometry that the slope of parallel lines will be equal. So if we're dealing with the slope of a line in this column, the slope of the line parallel is in this column right here. All right, those numbers are all going to be the same. Because the slopes of parallel lines are always equal. When we're dealing with the slope of a perpendicular line, though, we take the opposite reciprocal of a number. This involves 2 items. One, opposite means that we negate the number that we're given, so we change the sign. And then the reciprocal means we're going to flip the fraction. So here, if I'm looking at 2/3, the opposite reciprocal of 2/3 would be -3/2. The opposite reciprocal of 2 in the next example would be 1/2. We go from negative to positive, and 2 is like 2 over 1. So when we flip that, it becomes 1/2. 1/5 would become -5 over 1, or -5. The slope of a line that is 0, we know is horizontal. A horizontal line would be perpendicular to a vertical line. A vertical line has a slope that's undefined. And vice versa here, if we have a line that is a slope that is undefined, that would be meaning we are dealing with a vertical line. Vertical line is perpendicular to a horizontal line. Horizontal line has a slope of 0. So this will be a nice chart for you in case you ever forget the meaning of what opposite reciprocal is. So what we can do from there is write an equation of a line that is parallel to perpendicular to a given line. So as we look at this example, we are given a point, -1, 4, and then we have this line. x plus 2y equals 4. I graphed that down here, all right? So this is the line that we're given. What we want to do is construct a line that is both parallel and perpendicular to that line, but it goes through this point, negative 1, 4. So to just give you a visual of that, we're constructing two new lines. One of them will look like this. It will be parallel, all right? So what will be unique about that is it will have a different y-intercept, okay? What we need in order to write an equation of a line, as we've done in the past examples, is a slope and a y-intercept. Well, in order to calculate that, we first need to know what the slope of our original line is. So the slope of this line, we talked about this utilizing standard form. We can go negative a over b if we want, if it's not written in point or slope-intercept form. So negative a would be negative 1, b would be 2. So the slope of our line here is negative 1/2. If we're looking at the slope of the line that is parallel to that, it will also be negative 1/2. And we're utilizing this point negative 1, 4. So from here, we can go ahead and utilize point slope form. We would do y minus 4 equals negative 1/2, and then x minus a negative 1. And then from there, what we would need to do is solve for y. So we'd have y minus 4 equals negative 1/2 x. This will become plus 1 times a negative 1. So plus 1 times a negative 1 would be minus 1/2 as well. And then we would add 4. So our final answer for this would be y equals negative 1/2 x. And then negative 1/2 plus 4 would be 3/2 or 7 over 2. 3.5 or 7 over 2, sorry. We would do the same thing with the perpendicular line. However, the slope is going to be the opposite reciprocal. So what we're looking for with the perpendicular line is still going to go through this point, negative 1, 4, but we want it to form a right angle, okay? So the y-intercept is going to be different for the perpendicular line. So if the slope of our original line is negative 1/2, the slope of the line that will be perpendicular to that will be 2. We take the opposite reciprocal. From there, we can still use the same point that we did up here, negative 1, 4. So that would be y minus 4 equals our slope of the line that's perpendicular, which would be 2 times x minus a negative 1. This will become y minus 4 equals 2x plus 2. Be careful with the negative signs again there. And then we will have y equals 2x plus 6. And that is all.